Hi, today we're going to be talking about scientific notation, what it is, how to order numbers with scientific notation, significant figures, calculations, and then calculator usage. So scientific notation, also known as exponential notation, is a way to express numbers in two other numbers, a coefficient and an exponent term. And this is useful when we're dealing with either very large or small numbers. For instance, a car might weigh 1,320,000 grams, right? This is what we call decimal form because we could put decimal places behind it. Now, this is the same as 132,000 times 10, which is the same as 13,200 times 10 times 10, which is the same as 1320 times 10 times 10 times 10. Notice all I'm doing is each time I'm going ahead and I'm just reducing the one number and I'm just multiplying by a 10, right? This is the same as 13.2 times 10 times 10 times 10 times 10 and times 10. And then finally this is the same as 1.32 times 10 or times 6 tens. Right? 1.32 times 10 times 10 times 10 times 10 times 10 times 10. And I can write this as 1.32 times 10 to the sixth, where that 6 represents the number of tens I have to multiply it by. This is an example of scientific notation. So we took that number and we turned it into what's called a coefficient, that 1.32, and times 6, which is the exponent. Now our coefficient should be somewhere between 1 and 9.99. So it should be one digit, one non-zero digit, and then some others. It could be 1.32 or it could be 1.325, etc. It can have as many digits after that decimal place, but it should be between 1 and 9.99. After times 10 and then the 6, that's the exponent. Now, this can either be positive, like it is here, or negative. It could be negative 6. We'll show an example soon. Now, I showed you a way to calculate this, but it's really tough to do it that way. So an easier way is, if I have this number here, I could say, all right, here's the decimal place, and I want to move it 1, 2, 3, 4, 5, 6 places to get a number between 1 and 9.99. So it's 1.32 times 10 to the sixth. All right, now that's if I have a large number. Let's look at a small number. But before we do that, it's important to know that, I started off with this number. I turned it into this number. Those two numbers are the same. They're different ways to represent it. I could also write it as 13.2 times 10 to the 5 grams. This is also exponential notation or scientific notation, but it's not as standard as the other way, this way, because usually we want it between 1 and 9.99. But this is valid. 13.2 times 10 to the 5 is the same as 1.32 times 10 to the 6. I could even write it as 0.132 times 10 to the 7, right? Here, I would move over 1, and I would get 10 to the 6th, right? So all these are the same number, just different ways. But this is the standard way we would write it in scientific notation. So now let's look at a small number. So let's say we had a grain of sand and we weighed it, found its mass, and it was 0.00440 grams. Well, in this case, it's smaller. So if I wanted to do that trick, I would move it 1, 2, 3 times to the right, right? And that will get me 4.40. And because I had to move them to the right, it's now -3. I keep the units as grams. So what I did there was I took a small number and I turned it into a coefficient and then an exponent. But in this case, it's negative. So we have this way to look at big numbers and small numbers, right? And we could also do this for, a number like 12.0 meters. Well, we could write this as 1.20 times 10 to the 1 meters. Now, we generally don't do this because notice 12.0 meters, that's a number that's fairly reasonable to use, right? So we usually don't use exponential notation or scientific notation unless this exponent becomes either really big or really small, right? So if it's 1 or -1 or 2 or -2, we usually don't write it in exponential notation. But, in all these, hey, you could write it as this, and, that's understandable. We know 1,320,000. We could understand that. But let's say we had this. This is Avogadro's number, 6.022 times 10 to the 23. If you haven't covered that yet, you will soon and use it a lot in chemistry. This, if I were to write this in decimal form, it would be 6022 and then a whole bunch of zeros. This, we would never write it as this, right? Because that's just too confusing. So this is an example where the exponential scientific notation is really important to do. So now let's look at how do we order numbers using scientific notation. All right, so let's say we have these four numbers, 1.32 times 10 to the 6, 4.4 times 10 to the -3, 2.3 times 10 to the 4, and 6.1 times 10 to the 4. Well, if we have these, notice that they're all in proper scientific notation, right? This is a number, right, where you have one digit in front of that decimal place, right? And so if they're all in proper scientific notation, it's fairly easy. The first thing I do is I look at the exponents. So 6, 4, and then -3. The biggest exponent is the biggest number. The smallest would be the smallest number. Now notice 2.3 times 10 to the 4 and 6.1 times 10 to the 4. Both of those have the same exponent. So in that case, there we look at the coefficient, and then the 6.1, all right, that's going to be bigger than the 2.3 times 10 to the 4. So that is an example if they're all in scientific notation already. What if we had something like 320, right? We wanted to compare these 5 numbers. Well, in this case, I need to convert the 320 to scientific notation. So here's my decimal place, 1, 2. And so when I do that, I get 3.2 times 10 to the 2. All right, so now I look at it and I can say, okay, that slots right between the 10 to the 4th and 10 to the -3, right? And so that means that there I have my answer. Looking at scientific notation and figuring out significant figures all depends on the coefficient. So let's look at these two numbers we used earlier. 1.32 times 10 to the 6th. This 1.32 has 3 sig figs, so the entire number has 3 significant figures. This 10 to the 6th doesn't matter. In the same way, 4.40 times 10 to the -3, that also has 3 significant figures. This 0 is significant. Why? Because that decimal place. Let's say I wanted to write this as only 2 significant figures. Well, I would go ahead and I would write it as 4.4 times 10 to the -3. Notice the exponent doesn't change. I just changed the number of digits in that the coefficient. So that has 2 sig figs. If, let's say, I wanted to write it with 4, I would add on another digit to that coefficient. This would have 4 significant figures. So in chemistry, we're going to use scientific notation, and we're going to do calculations involving them. A little later, we'll show you how to use a calculator for that. But for now, let's just do it separately, and then we'll figure out and we'll see that they're the same answer when we use the calculator. So if we had 1.32 times 10 to the 6th plus 2.8 times 10 to the 5th, and we wanted to add these, right? In addition and subtraction problems, you need to make sure that you have the same exponent. So let's say I have 1.32 times 10 to the 6th plus 2.8 times 10 to the 5th. I need these to have the same exponent. So what I'm going to do is I'm going to convert one of these so that they have the same exponent. So I'm going to go ahead and I'm going to convert this one right here. So 2.8 times 10 to the 5th is the same as 0.28 times 10 to the 6th. So now I'm adding up these two numbers. They have the same exponent. So now I can just take 1.32 plus 0.28, and the exponent remains the same. So when I do this, 1.32 plus 0.28, that gets me 1.6. And notice these both have two decimal places, so I have two decimal places. So I'd get 1.60 times 10 to the 6th. Again, we'll do it later in calculator, see that it's the same number. So now for multiplication and division, it's a little bit different. First, for multiplication, when we have two numbers in scientific notation, we multiply them. Notice we have 1.32 times 10 to the 6th times 2.8 times 10 to the 5th. In these two cases, I just take the coefficients, the numbers in front, I multiply those, and then my exponent is the sum of the two exponents. So I have 1.32 times 2.8, so that gets me 3.696 times 10 to the 11th. Notice this has 3 sig figs, this has 2 sig figs, so I need to then round it, so it's 3.7 times 10 to the 11th. In division, it's a little bit different. Here we have two numbers, 2.4 times 10 to the 8th divided by 5.2 times 10 to the negative 2. Right? This may also be presented as 2.4 times 10 to the 8th over 5.10 times 10 to the negative 2. In this case, we go ahead and we take those two coefficients, divide one by the other, and then it's times 10. And instead of adding like we did in multiplication, now we subtract. So it'd be 8 minus the negative 2. And so when I do this on my calculator, I get 2.5 divided by 5.1. So that's going to get me 0.4706 times 10. I'm taking 8 minus 2, so that's 10 to the 10. All right, now when I look at this, this is in exponential notation. This is the answer. But notice this is improper. Usually we want this number, the coefficient, to be between 1 and 9.99. So what I do is I move this towards the right, and I would get 4.706 times 10 to the 9. This would go down because the coefficient's going up in value, so the exponent has to go down in value. So I'd have 4.706 times 10 to the 9th. This has 4 sig figs, but originally I only had 2, so I'm going to round it to 4.7 times 10 to the 9. Now let's do that same calculation, but with a calculator. So this is a calculator with the EE button, and this actually makes life easier. So I can put 2.4 EE8, that just stands for exponent, and I divide by 5.1, same thing. But here I have to make it 2, and I use this button here to make it negative. And so when I do that, I get this number here. That's not in scientific notation, but I can convert it to scientific notation. So here it is, 1, 2, 3, 4, 5, 6, 7, 8, 9. So then I'd have 4.7 times 10 to the 9. I can also, with this calculator, use second function and scientific, and now I see 4.7 times 10, and I see this 9 right here. Sorry, I need to get it refocused. Right up there to the 10 to the 9, right? Okay, so that's one calculator. Let's try a different calculator. So your calculator may be different. That's okay. You just have to get used to it and try it out. So this is a different calculator, but it again, instead of that EE button, it has this times 10 to the X. So for this one, I go, let's see, 2.4 times 10 to the 8th divided by 5.1 times 10. This one's different than the last one. The last one I could put the 2 and then make it negative. This I have to make it negative before. And then I press enter. And I get that 4.7 times 10 to the 9th. Let's do that one more time. 2.4 times 10 to the 8th divided by 5.1 times 10 to the negative 2 equals. So that is two different calculators doing it. The one thing that's common between these two is they have either EE button, or in this case, the times 10 to the X. All right, here we have a different calculator. This one doesn't have the EE or the times 10x. It does have a 10x one, but this one works differently. Some of you may have this one. You can see the model up there. So for this one, I have 2.4. I'm going to do it the wrong way first. If I do 2.4 times 10, notice it has that open parentheses, so I have to put an 8 and then close the parentheses. And now I go ahead and I divide by 5.1, and I'm going to do the same thing, times 10 to the negative, I put this negative here, 2, and close the parentheses. And let's see what I get. I get this number right here. It's 4,705,88.2353. Okay, so you can't quite see it perfectly. 0.2353. This is not the same, right? This would only be 4.7 times 10 to the 5th. So something's wrong. And the reason why it's wrong is the calculator thinks that what you want to do is you want to take 2.4 times 10 to the 8th, divide by 5.1, and then multiply by 10 to the negative 2. So what you have to do on this calculator is put parentheses around there. Okay, so let's do it one more time. So if I do 2.4 times 10 to the 8th, close that parentheses, divide by, use parentheses again, 5.1 times 10 to the negative 2, close that parentheses, then close that parentheses, equal. Now, notice that period is now over here, right? So it's 407, in this case, 470,588,2353. So here, I move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So I'd get 4.7 times 10 to the 9th. So this case, it works, but I had to use those parentheses, right? It's on the screen right here, right? That parentheses, and then I had to close it, okay? Your calculator may be different. You just have to try it out. All right, so that concludes talking about scientific notation, right? We started off looking at what is it and how do we convert, right? So if you have a number like this that's big, you go ahead and move the decimal point to the left, and that means you get 10 to the 6th in this case. If you have something that's small, you'll have 10 to the negative something. Then we went ahead and we looked at ordering numbers in scientific notation. The key thing is that they all have to be in scientific notation or all in decimal form. Either way works, but you can't just take these numbers where some are in scientific notation and some aren't. You have to convert them all so that they'd all be in scientific notation. Then we looked at significant figures. Remember, it's only the coefficient that matters, right? Not the exponent up here. That doesn't matter when you're looking at significant figures. Then finally, we looked at calculations. And we went in and we did them by hand. But the key thing is you can also do them on calculator. But for your calculator, bring it with you, use it, ask someone, either me or the instructor or a discussion lead, and we'll try to figure out. Or just type in your calculator's model number, which is usually on the top, right? And scientific notation, and you'll see videos that go through it, okay? Just make sure you do that before a test because you can't learn it during a test. All right, goodbye.